Video 2 starts off with the second story problem. Now, here's the thing. I typed this up at school, and I typed it up yesterday morning or Wednesday morning, so I don't remember what names I switched. So it might be Ben and it might be Gabby. I'm pretty sure it's Ben and Gabby, but I don't know whose name I changed here. So basically what I do is I take the names from the problems in the book, and I just switch out names for students in the classroom. But anyway, let's talk about this problem. Sophia says she knows the way for Ben and Gabby to eat half and a quarter of the cherries and still have 50 left for the pie. First, divide the cherries equally so that Ben and Gabby each get the same amount. Ben eats one half of his, and Gabby eats one quarter of hers. Will this leave enough cherries for the pie? Why or why not? Now, let's check and see what Sophia, or whatever other name I put on there, is doing. Plan. So we're going to start with our 80 cherries. And the first thing we're going to do is we're going to divide equally, so each of them gets the same. So we're going to have Ben, and he's going to get 40, and then we're going to have Gabby, and she's going to get 40. Now Ben is going to eat half of his. So what are we? Ben is going to eat half of his, so we're just going to take half, and we're just going to split this into 20 and 20, and we're just going to cross these out because these are now in Ben's belly. Okay, Gabby, she's going to eat a fourth of hers, so we're going to take this number right here and we're going to divide it into 4 parts. 1, 2, 3, 4. Okay, so 40 divided by 4 is going to be 10, so 10, 10, 10, 10, and these 10 go in Gabby's belly. Now, how many do they need to bake a pie and still have 50 left for the pie? So let's see how many they have. We have, change colors here. We have 20 plus 10 plus 10 plus 10, 20, 30, 40, 50 cherries left. Now, when we think about this, did Ben still eat half? Yes, he just ate a half of a smaller amount. Gabby still ate a quarter of the cherries. She just ate a quarter of a smaller amount. And that's how fractions change value. And that's how they change value. And that's how they're different, is because it all depends upon what the whole is. The whole in this case was 40, and half of it was 20 versus 80, and half of it being 40. And if you ate 40 cherries, I think you would probably get sick. I'm not sure though, but I would venture to guess. All right, let's talk about the runners on the race. So give me a second to type that up, and why don't you guys cut it out and glue it to get ready to go. All right, the problem says the 4 runners on a relay team all want to run the same distance in a race. The coach says the first runner will go 1/4. Oops, that's not the right one. Will go 1/4 of the distance. The second runner will go 1/3 of the remaining distance. The third runner will go half of the distance that is left at that point. The fourth runner will finish the race. Will each runner run the same distance? Why or why not? Now, as we read this problem, we have 1, 2, 3 completely different fractions. And then we have the fourth runner, which we don't know the fraction whatsoever. So let's figure out, are they all running the same distance? First thing we're going to do, we're going to draw the race. Now, they might be running a race in a circle or maybe in an oval, but we're just going to draw this race as a straight line. And we're going to say that the first runner is going to run 1/4 of the distance. So the first thing we're going to do is we're going to cut this into 4 pieces. And we're going to take the first runner number 1, and they're running 1/4. Ta-da! So that's 1/4. The second runner will run 1/3 of the remaining distance. Now, boys and girls, here's the thing. This right here is the remaining distance. And the second runner is running 1/3 of that. Well, how many chunks are left? Why, there's 3 left. So if the second runner runs 1/3, we're going to get rid of this piece right here, because this is 1/3 of what is left. 1/3. the third runner will go 1/2 of the distance. So now we have to figure out they're running 1/2 of what is left. So let's draw what's left. And let's run 1/2. 1/2. And then finally the last runner is going to run whatever is left, which is right, oops, that's not the color I want. Oh shoot, I already ended. No, bummer, I just lost everything. Oh, now it all came back. Okay, this is what's left, and this is 1/4. This is what's left. Now, these are, we put it all in 3 different drawings, and, well, technically 4, but let's put it all in one drawing. So the first runner is done. Now, let's look at the second runner. They're running, that looks remotely like 1/4. The third runner looks like they're running the same as 1/4. And then the fourth runner, let's go with a nice bright color here. They're running 1/4. So what the question is, the fourth runner will finish a race. Will each runner run the same distance? Why or not? Why not? Well, yeah, they're all running the same distance. They're all running 1/4 of the race. It's just depending, we change the whole, we change whatever the entirety each time. So there it is. And that's what lesson 5.5 is about. Next 2 videos will deal with lesson 5.6.